In the last 50 years, the world's population has doubled, currently exceeding 7 billion inhabitants. Cities do not stop growing, building up infrastructures, land use experiences changes, and natural resources exploitation increases. All this creates a strong impact on water availability, so essential for the financial growth and the public needs. One of the most important factors is climate change.
In order to assess and predict climate change, reasonable numerical models are used to provide climatic scenarios that take into account greenhouse effect emissions. In Mediterranean area, these scenarios show a significant variability of the spatial-temporal distribution of precipitation together with an increase in temperature. It seems that, for example, there will be more floodings in some areas, and on the other hand, maybe the same areas or some other ones can be affected by severe droughts, more intense and longer.
So before mortgaging our future for the lack of something as vital as water, it is essential to anticipate and build up a good management scheme. But first of all, predictions should be made in order to satisfy our needs for the coming decades, taking into account all the changes.
Water Change is a 3-year life-funded project which started in 2009. Its aim is to propose a methodology and a tool to help decision makers to assess the impacts of global change in a river basin and to propose adaptation measures.
Aqua Water Technology Centre, together with CRAI, the Centre for Applied Research in Hydrometeorology, work together to conduct the water change project within the EU programme LIFE. The contribution of these investigation centres with the work of different stakeholders has allowed to design a methodology and a powerful tool which gives us an overview of the river basin, combining hydrological and water management models.
La herramienta que hemos desarrollado, el Water Change Modeling System, permite vincular diferentes modelos del ciclo del agua, como modelo hidrológico, modelo de gestión y modelo de calidad de agua. Esto permite simular diferentes escenarios de cambio global que van a representar los diferentes cambios posibles en la cuenca a nivel de uso del suelo, de clima y de uso del agua.
This way, it is possible to anticipate the consequences and suggest adaptation strategies for the medium and long term, knowing in advance their costs and benefits. In summary, this allows us to plan the work that has to be done in a basin in order to gain the maximum hydrological efficiency, taking into account all possible scenarios.
El riu Llobregat, juntament amb el riu Ter, el Besòs i els aqüífers del Llobregat, i ara actualment també una dessaladora, són els elements que abasteixen a Barcelona i la seva àrea metropolitana. L'estudi del Water Change aplicat a la conca del Llobregat és essencial per veure si a llarg termini totes aquestes infraestructures que hi ha són perdurables i sostenibles en el temps.
The Llobregat River has its source in the town of Castellar de n'Hug, at an altitude of 1,259 meters in the middle of the Catalan Pre-Pyrenees. After crossing the plain of Bages, the river reaches the Litoral Cordillera, beneath Montserrat mountain, and then enters into the gorge of Martorell, forming a small swampy delta in the Mediterranean Sea after a course of more than 170 kilometers. The watershed has a surface area of 4,948 square kilometers and contains important reservoirs such as La Baise, with a volume of 109.5 cubic hectometers, and La Losa de Cabais, with a volume of 79.4 cubic hectometers. In the upper watershed, forests predominate in the area. In the lower part, the area is heavily industrialized and urbanized, ending up right beside the Barcelona airport. the waters of the Llobregat watershed nourish an important part of the entire metropolitan area of Barcelona, with a population of more than 3 million inhabitants. This means that a large part of the available resources of the watershed are being used and that the supply will depend on the future rainfall.
The Llobregat Basin represents a great opportunity to test the water change modeling system. Its water resources are under pressure because they are used for several purposes like irrigation or water supply. During the last decades, for example, the Llobregat Basin has been affected by a severe drought, while generating a significant deficit between water demand and water supply.
The model allows to introduce different scenarios of global change, like, for instance, water demand data influenced by the demographic variation, and also influenced by climate change, and water availability data influenced by changes in precipitation, temperature, and land use. In the long run, most of the scenarios predict a temperature rise and a decrease of the precipitation in our area.
We established future scenarios combining together different factors of change such as land use, climate change, and future water demand patterns. On the one hand, water demand is likely to increase with population growth and higher temperatures. On the other hand, most climate scenarios predict less precipitation and an increase in temperatures, which leads to less water available. So all in all, global change will have an important impact on water supply in the Llobregat Basin.
In this situation, more intense and lasting droughts are being predicted than the one of 2007, implying strong impacts on the population and the economy.
We simulated a total of 65 scenarios of global change, and our results show a quite evident trend towards an increase in water deficit. It is likely there will not be enough water to supply demands in agriculture, the environment, and in urban areas. In our predictions, in the worst case, the mean yearly deficit could reach 30% of the demand as of 2100 in the Llobregat Basin.
Thanks to this information, hydrographic basin managers can perform actions to try to mitigate the expected negative effects and thus largely offset the future water problems.
Hemos aplicado dos tipos de medidas en el caso de estudio. Primero, las medidas que quieren aumentar el recurso, como la desaladora o la recarga de los acuíferos. Y también hemos aplicado medidas que tendrán a disminuir la demanda, como una mayor concienciación pública o la disminución de las fugas.
La mayoría de los escenarios de cambio global indican que se van a asumir unos costes significativos debido a los efectos de la sequía. Cuanto más nos adaptemos, menores costes asumiremos en el territorio, pero esta adaptación no está exenta de coste. Podemos definir diferentes combinaciones de medidas de adaptación que permitan reducir el déficit hídrico en los próximos años. Y este modelo nos ayudará a encontrar esa estrategia óptima. Esta estrategia será aquella que permita evitar el mayor número de daños posibles en el territorio a un menor coste de adaptación.
So far, the good management of resources along with an aware population has overcome all the setbacks. However, the predictions for 2030 point to even more severe droughts. The different scenarios show the difficulty of predicting what will happen in the future. However, we can see a high probability that the demands could not be totally satisfied if we do not adapt. In 2030, about 10% of the total demand could fail to be supplied. And in the worst case, a third part of the demand could fail to be satisfied in 2100. So adapting in advance is essential. For instance, carrying out different adaptation measures to ensure water supply until 2040 would imply annual costs equivalent to 0.1% of GDP of Catalonia. But the cost of not adapting is even worse. Droughts create economic losses due to restrictions in industrial activities and a loss of population welfare. The costs carried by the society would be around 4% of Catalan GDP for the years affected by a drought.
El proyecto permite tomar decisiones, permite analizar ese futuro y permite ver cómo se deben afrontar los problemas que se prevén que se puedan presentar. El proyecto tiene no solamente la visión de la cantidad de agua, tiene la visión de la calidad del agua y tiene la visión económica, y esto es un avance importante sobre muchos de los proyectos que se han hecho hasta ahora que se limitaban a la parte hidráulica.
The tool developed at Water Change wants to be useful for river basin authorities and water companies in their medium and long-term planning activities and decision-making processes. It is especially oriented to support the environmental policies that will be related with the Water Framework Directive.
The Water Change project, thanks to its methodology and tools, helps to find the balance between the prediction of future water availability and the knowledge of how, where and when to invest in order to obtain the maximum hydrological efficiency in the basin.